All right, so we're back for part 3 in this beam deflection calculation using the double integration method. And so far we found using a couple other boundary conditions here, that C1 and C2 were 0, using these two boundary conditions, that the displacement at 0 at the fixed support is 0 and the slope at the fixed support is 0. And so I took the liberty of rewriting the equations that we have here. So this is, for the slope function for segment 1, and then slope displacement function, or the equation of the elastic curve for x1. And these are my two equations with the constants already introduced for us here. Bam, bam. All right, now we want to apply the other two boundary conditions where the two functions meet, where x1 and x2 meet. And here, what we have are, I just rewrote the boundary conditions for us. So I'm just going to apply these one at a time. So I'll start with this theta 1 equals theta 2 here. And I'll have here, I just want to plug and chug straight up EI here. So EI of theta 1 x1 is equal to, let's see here, here EI of theta 1 x1, or at 5 meters, is equal to, this is negative, of EI at theta 2 at 5 meters, right here. And you can see that the EIs, because they're constant and, well, they're going to be the same, they just cancel out right here. So I have here, this to solve for C3 now is, I'm going to go down here to the other page here. This will be 5 halves kilonewtons times 5 meters squared minus 37.5 kilonewton meters times 5 meters is equal to this right here. Oh, I don't want to forget the negative. I almost made a big mistake. So this negative right here, this negative, times minus 5 meters cubed over 6 times kilonewton per meter plus C3. And then I can just straight up solve for C3 right here. And when I run my algebra, I just get that C3 is equal to 145.833, repeating, kilonewton meter squared. Okay, so there's my C3. And now I can go to the next relationship and apply this boundary condition here. And let me use like black again here for that last boundary condition. And I'm just going to go straight up. Again, look, check this out. EI V1 of X1 is equal to EI V2 of X2. And so these EIs just cancel. And here got to put the 5 meters in there. That at 5 meters, bam, right here. And so this V1 at 5 meters, the displacement at 5 meters is 6 kilonewtons times 5 meters cubed minus 37.5 kilonewton meters divided by 2 times 5 meters squared is equal to minus 5 meters to the 4th divided by 24 plus C3, which was 145.833 kilonewton meter squared times 5 meters plus C4. And now I just solve for C4 again here. So after some, just straight up math, right? I just calculated these numbers out from these groups right here. I forgot there should be a kilonewton per meter here. Just make sure, just so your units work out. And so now I've got these and I just add or subtract. And so I'll get C4 here is equal to negative 1067.71-ish kilonewton meter cubed right here. So now I've got all my constants, and finally what I can do is go back and plug and chug into my constants over here. And let's see, I've already got equations for this. And so here for this one right here, I would just put in C3 is, what was that? That C3 was 145.833 kilonewton meter squared. And same thing here. This would be that 145.833 kilonewton meter squared. And then C4 would be negative 1067.71, negative 1067.71 kilonewton meters cubed. And the units might look a little fishy, right? But you just have to remember this EI is sitting over here on the left, and this has units of kilonewton meter squared here. So when I divide this through, I'm going to get units in this displacement function. I'm going to get units of displacement or length. And that'll work out fine because all these are kilonewton. Everything here, every term here is kilonewton meter cubed, right? So I'll just end up with a meter. And then same thing here. For slope, I should have no units. And so this is kilonewton. Every term here is kilonewton meter squared, and this is kilonewton meter squared and sitting out here. So to get the actual values at any specific point at x2, let's say, I just got to make sure I divide by EI, right? Okay, so hopefully that was insightful and useful, and you're using it. But just remember those boundary conditions. All right, enjoy. Take it easy. Let me know if you have any questions. Bye.